This is the iodine clock reaction lab, where we're going to look at how the rate of a reaction is affected by temperature and concentration. Our reaction today is kind of complex, but we'll just say chemical A is reacting with chemical B. When they react together, you'll see a color change. In our first trial, we're going to measure out 10 milliliters of B and 10 milliliters of A. And we'll put A into this beaker, and then we'll add B to it. When I add chemical B to it, you should start your stopwatches because we're going to time how long it takes this reaction to go to completion. So we'll start our timers right now, and I'll stir that a little bit, and then we'll let it react. These are reacting at room temperature, and so today that's about 19 degrees for these two things. So 19 degrees, this is the first trial with 10 milliliters of A and 10 milliliters of B. And there, the reaction just happened. You saw the color change, and so now you would stop your stopwatch right when the color change occurred. And now we're going to do some other trials with other concentrations. In our next trial, we're going to have 7 milliliters of A. And we'll combine that with 3 milliliters of B. Sorry, 3 milliliters of water. So the water is to dilute A and keep the total volume the same. So I'll put those in here. And then still 10 milliliters of B. So this time we're using 7 milliliters of A, but our total volume stays the same. So we'll pour that in. We'll mix it a bit to get started. And you can time how long that takes to have a color change occur. While we're waiting on this one, I'll start to prepare for the next one. The next one's going to be just 3 milliliters of A. 7 milliliters of water to keep our total volume the same, and 10 milliliters of B, as always. So we'll combine these over here. You can start timing this one as soon as I pour in chemical B. Okay, so you can see that our second trial has gone to completion. We're watching our third trial now. The third trial has the lowest concentration of chemical A, and we'll see how that affects the reaction rate or how long it takes for the color change to occur. In our fourth and fifth trials, we're going to be varying the temperature. So I have this beaker of A and B that were on a hot plate, and these two have been warmed. And so I'll pour these two together. We'll measure how long these take to react. This one is about 40 degrees Celsius. And then this one has been on ice. This one is our cold one. And this one was starting at about 7 degrees Celsius, and we'll see how long that one takes as well. So this was our hot one. This was 40 degrees. It was 10 milliliters of A and 10 milliliters of B. So you can compare that to the first trial that we did, where we had each one at 20 degrees Celsius, or 19 degrees Celsius, which is room temperature today. This right here is our third trial. This was the lowest concentration of A. So this one's taking a little bit longer because the concentration of A is low. It was only 3 milliliters of A. And then over here we have our cold one. The cold one was the same concentration as the warm one. It was 10 milliliters of A, 10 milliliters of B. And just the temperature was varied in this, our 5th trial. Okay, our 3rd trial, the one with 3 milliliters of A and 7 milliliters of water to keep the volume the same, and then 10 milliliters of B has just changed color. So if you started a stopwatch when that one began, you can figure out how long that one took to occur. Now we're just waiting on our 5th trial, which was the cold solution. All right, our 5th trial, the cold one, has just gone to completion, and you can record how much time that one took. And now you have all the information. You can compare the first 3 trials, which was the highest concentration of A, and then on to lower concentrations of A. You can compare their speeds. And then you can compare the 1st trial and the 4th and 5th trials to look at the effects of temperature.